everyone, welcome back. This is chapter 10, problems, and we were going to work on problems 4, 5, 6, 7, and 8 in this video. And first three problems, right, are basically they have answers, but more importantly, I'm going to work across different videos. So we're working on 4, 5, 6, 7, 8. In another video set, I'm going to work on 9, 10, 11, and 12. These are multiple choice questions that I'm working on. And 14 through 18, and then 19 through 22. So it's going to be 4 different videos. And once you learn how to work on these multiple choice questions, you will actually have much easier time to understand these longer form questions. Not only that, also these longer form questions have detailed solutions. So let's work on these questions that I mentioned. So in this part, again, we are working on questions 4, 5, 6, 7, and 8. So without further ado, I know you know that I am no nonsense. I don't like to waste anybody's time. So let's get started. Which of the following specifications could not be employed? Okay, so in questions, be careful. Could not be employed. There's a negative, right? For estimating short-run production function. Okay, so first of all, short-run production function needs to only depend on labor. Labor is the only variable input, and we focus on cubic production function, right? Cubic form, that means third power, up to third power. So we are used to seeing these kind of production functions, third power, right? And labor is the only variable input. What are these A's and B's? So A, for instance, is little a, k bar raised to the power 3. And B, capital B, is little b, k bar raised to the power 2. What does it mean? So we have actually a cubic production function looking like this. K raised to the power 3, L raised to the power 2. So this is general form. This is cubic production function. Okay. In this production function, both K and L are variable. That means you can change according to this form. You can both vary capital and labor. But in the short run, labor is variable. Short run is a time period. At least one input is fixed. In the long run, everything is variable. There's nothing fixed. Okay, so having talked about, this little bit background information, so which cannot be employed for estimating short-run production function. This can be employed, so this is correct. So let's see this one. So this is AK plus BL. So we can't use this because this production function is going to be linear and it's not going to have the properties we want. We won't have a nice total product, average product, marginal product. Actually, with this one, marginal product is 0, so it's ridiculous. Okay, so it says last unit of labor brings what? 0 additional output compared to the previous worker. Okay, so it's constant. So you can't use this one. This one we can't use it because capital is variable here, even though it has cubic form that's desired, but capital is variable. So these are the not, right? So we're looking at not. Therefore, A and B are not, they cannot be used. All right, so question number 5. Which of the following represents short-run cubic production function? This is really easy, right? We talked about this. So this is a cubic production function, but it's not short-run because capital is variable. This is not cubic because it's second power. Let me make it a little bigger. It's too small. So this is not cubic because there's no third power here. So this cannot be a short run because capital is variable. Let's take a look at, okay, cubic third power, but it is, what do we have here? Okay, so cubic third power, A times, capital A times L raised to the power 3, okay? B, capital B times L raised to the power 2, and A defined as this, capital B defined as this. That's correct. This is not correct because this is not cubic, quadratic, second power. So correct answer is C here. Let's go to the next question. All right, so with a cubic production function, okay, in order for average and marginal product functions to have their usual theoretical properties, what must be the case? So I don't usually do this, but I'm just going to work on this. L raised to the power 3 plus B, K raised to the power 2. Okay, so what is average product? Average product is Q over L. Okay, so I'm just going over it. We are not going to derive this. I'm just showing you. Let's call this capital A. Let's call this capital B. So average product is A, L raised to the power. This is supposed to be 2. Oh my gosh. This is power 2. So if you pinpointed that mistake, you are doing good. All right, divided by L plus B, L raised to the power 2. So this would be A, L raised to the power 2 plus B, L. Okay, what's marginal product? Marginal product, so I'm going to rewrite the cubic short-run production function. And marginal product is first derivative of quantity with respect to labor. So third power goes up front, 3A, L, lower the power from 3 to 2, plus 2, this 2 comes up front. That's all you need to know from differentiation. Don't be scared of calculus. 2 minus 1, it's going to be 1. Okay, first power. So I just derived these. These got nothing to do with this question. Everybody's like, why did you do it? I did it because I just love to, I'm sorry, but I just love to go over concepts while I'm solving questions. All right. So the correct answer is, for it to have good properties that we're looking for, okay, you have to have A negative, little a negative, and lowercase b positive. So what are we paying attention to? The cubic, the coefficient in front of the cubic form of labor needs to be negative, and the coefficient in front of the quadratic needs to be positive. You can watch my lecture slides, and there I derive it, but it all comes from the fact that we need, right, average product and marginal product curves, labor quantity. They have this concave, we call it, this is concave. You want a concave, this is convex. Okay, so you want a concave shape. Let me rewrite it. Concave. Okay, so for it to have a concave shape, you want the second derivative of this guy to be negative. So second derivative is going to be 2, right? 2a only. You want 2a to be negative. Okay, so you want first derivative to be positive. So it all comes from calculus. But long story short, for capital A to be negative, you need little a to be negative, because capital is always positive, right? So positive number raised to the power 3 is positive. You want this guy to be negative, little a. So everything comes from calculus. What are your options? I can't memorize stuff, so I literally derive everything, but you can just memorize. Oh, okay, I have cubic production function, right? A, K raised to the power 3, L raised to the power 3, B, K2, L2. Guess what? You can be like, oh, this needs to be negative, this needs to be positive. You can memorize, or I derive everything literally all the time, because I am not very good at memorizing, but you be better, you can memorize. 7, or know where it comes from. That's the most important thing. Question 7, when estimating short-run production function. Okay, so this is in, Excel, we are running regression. And if you watch my lecture slides, you'll learn, right? It's necessary to specify. So we are looking to see if A and B, A is negative, B is positive, but you cannot put that restriction in the program. Why? Because some production functions will not have that shape. That's okay. but you have to make an adjustment. Remember, in the lectures, the intercept term is forced to 0. Why? Because there is no intercept here. Do you see an intercept? A, little a plus b, you know, integration bx plus c, z, whatever. So this intercept is not here. You immediately start from the origin. So it looks like this. It starts from, so basically what it says when there's no intercept, labor quantity, if you hire nobody, you produce nothing. So that's what it means to force intercept to be equal to 0. Next question. Oh, this is a fun question. Question number 8. An average variable cost is given. Cool. Now we are in the cost curves, okay? And we are also doing cubic cost function. Total cost is going to be cubic. Average variable cost is given. Okay, I'm going to write it down. 96 minus 2q plus 0.05q raised to the power 2. Perfect. Which of the following cost functions is associated with this estimate? Look, I'm just going to work on it. So total variable cost, let's find total variable cost. Total variable cost is going to be, right? Actually, I'm going to go from reverse. Average variable cost is total variable cost divided by Q. Yeah? Average variable cost, total variable cost divided by Q. So then if you do cross multiplication, then total variable cost is going to be average variable cost times Q. So if you multiply the whole thing with a Q, let's do it. 96 minus 2q plus 0.05q raised to the power 2 times q. This spreads over each term in the parentheses. Okay, so it's going to be 96q minus 2q raised to the power 2 plus 0.05q raised to the power 3. This is where cubic cost function comes from because it's power 3. Okay. So let's see if we can find this. 96q, okay, minus 2q raised to the power 2. This one, okay, this one also. So B is definitely true, but don't stop because it also put marginal cost, short-term marginal cost. So short-term marginal cost, right, you can do the first derivative of total variable cost, right, with respect to quantity, right? In English, what it means is that if I increase output by 1 more unit, let's say I'm a car producer. I'm going to draw, looks like a purse. Okay, let's say I came up with this smiley face car brand. I'm just making it up. But this is fully electric and amazing. Let's say 600-mile range. And it's only $15,000. We're in a multiverse, okay? Parallel universe, multiverse, and this car exists, and it is only $5 to charge per month. That's amazing, given the gas prices. Okay, so what short-term marginal cost curve says that if I produce one more car, what's the increase in total cost, right? How much is this car costing me? Okay, so I'm selling it for $15,000. This last car better cost. We'll get there. But first derivative 96q, this is power 1. 1 goes up from 96. 1 minus 1. Power 0 means it's just become 1. So it's this q raised to the power 0. Anything, $1 million. So if I tell you I'm going to give you $1 million raised to the power 0, I'm actually telling you I'm going to give you $1. $10 raised to the power 0, I'm going to give you, or I'm going to give all my students $1 billion. Oh my gosh. Right, is that a billion? Okay. That's actually 100. All right. It is what it is. Power 0, it's actually $1. Okay, you can actually joke to your friends. All right. So q raised to the power 0 is 1. Negative 2, this 2 comes up from negative 4, q raised to the power 1. Plus 0.05 times 3, this comes up from 0.15 plus q raised to the power 2 reduced to power by 1. That's it. So this actually matches This guy matches with it. So which ones match? I can't delete this. It's okay. So both D and B. So correct answer is E. And I'll see you in the next video where we will go over questions 9, 10, 11, and 12.